In this video, we're going to go over section 1.6 of our textbook, which goes over applications of linear equations. And so what we're going to do is follow this four-step process in order to do this. So first we'll read the problem and make sure we understand it and definitely assign a variable to what we're being asked to find. Then we'll write an equation that will relate the quantities that we're given. And then we will solve the equation like how we've been seeing it in the last couple videos. And then lastly, we'll just look back and make sure that what we got seems reasonable. So the first example we'll look at, we're told that some number represented by y is 6 more than 2 times a second number represented by x. What we want to do is write an equation to find the two numbers given that their sum is 51. So what we're going to do, in this example, we were already given our variables. Y is our first number and x is our second. But what we can do is essentially translate these words into an equation. So first, we'll break it down. So we have that y is equal to 6 more than 2 times our second number, x. So that's what our equation would be. 2 times some number plus 6 is going to be equal to y. And we want to write an equation to find the two numbers given that their sum is 51. So we're also told that the sum of the two numbers, x and y we're looking for, is equal to 51. Right? So using this information, what we'll do is we'll rewrite this equation, or one of them, in terms of the other variable. So what I mean by that is, if I were to plug in y into this equation here, we know that y is equal to 6 plus 2x. So I have 6 plus 2x for y there, and this is equal to 51. So we're just plugging in the equation that we have for y, so that we just have one variable in this equation, and then we can easily solve for it. And then what we'll want to do is plug that back into our equation here to find our first number. So at this point, we can just solve for x. We have x plus 2x, so that's 3x plus 6 is equal to 51. Taking away 6 from both sides, we get that 3x is equal to 45. And then dividing by 3 on both sides, we get that x is equal to 15. Now plugging that into our equation for y, we get y is equal to 6 plus 2 times what we got for x, which was 15. Then we get 6 plus 30, so that'll be 36. Right? So not too bad once you're able to translate these words into an equation. And then lastly, we're going to look back and check our solution if possible. And then you notice that if you were to add 36 plus 15, you would get 51. So our solution does make sense. Okay, so the next example we're going to look at is the following. So we're told that a basketball team scored a total of 80 points in a game. And there was a total of 37 2-point and 3-point baskets. And we're asked how many 2-point shots they made and how many 3-point shots they made. So you want to write a linear equation that'll model this situation and then solve. So the first thing we're going to do is assign variables to the things we're trying to find. So we'll let x represent the number of 2-point shots, and y represent to the number of 3-point shots. And then we're told that there was a total of 37 2-point and 3-point baskets. So this means that the sum of the 2 and 3-point baskets will equal 37. We're also told that they scored a total of 80 points in the game. So this means 80 is going to equal the total number of points, and each 2-point shot is worth 2 points. So we have 2 times the number of 2-point shots. plus every 3-point shot is 3 points. So we have 3 times the number of 3-point shots. Okay, so this represents the total number of points scored in the game. And then we'll do the same thing that we did above. We will rewrite our equation in terms of one variable. So let's find x first. And you can find y first also, whichever you feel like. But we're going to find x first. So I'm going to solve for y here. So y is equal to 37 minus x. And then I'm going to plug this information back into this equation. So we get 80 minus 2, 80 is equal to 2x plus 3 times y. And y is equal to this. So we get 37 minus x. All right, then we'll distribute this 3 to both of these terms here. So we have 80 is equal to 2x plus 3 times 37 is, right? Okay, yeah. 111, and then minus 3x. And then we'll combine all of our like terms here. We have just our constants, and then we also have our variable terms here. So I'll take away 111 on this side and this side. And so then 80 minus 111 will be negative 31. And then we're going to combine this negative 2x, or sorry, this positive 2x and this negative 3x. So we'll get negative x here. And then we have a negative on both sides, so these guys will cancel, and we just get that x is equal to 31. All right, so that is the number of 2-point shots in this game. And then to find the number of 3-point shots, we'll plug our number of 2-point shots into our equation for y. And so we get the number of 3-point shots is equal to 6. All right. And then the last example we're going to look at is the following. So let's say we're told that a group of friends is organizing a bake sale, and their initial expenses for baking supplies for $50. Each cupcake is going to cost about 10 cents to make, and they sell each cupcake for 15 cents. And we're told to let x represent the number of cupcakes sold. So the first thing we want to do is express the cost as a function of x. Sorry, there's a lot of typos here. Function of x. So we have our cost function is going to be c of x. And we know that we have an initial cost, or a base cost, of $50. And we know that for every single cupcake, it costs 10 cents to make. So that's an additional 10 cents for every single cupcake, and we're told that x is going to represent the number of cupcakes. So we have plus 0.1 times x. Next, we want to write the revenue as a function of x. So we have r of x. And we're told that they'll sell each cupcake for 15 cents. And so our revenue is just going to be 15 cents, so 0.15 times each cupcake that they sell. Now, if we want to find the value of x for which revenue is equal to cost, we're going to set our revenue equal to our cost. Doing so, we know that our cost function is 50 plus 0.1 times x. And our revenue function is 0.15 times x. And what we can do is solve for x. So I'll combine our like terms. So we'll take away 0.1x on both sides. And so we get 50 is equal to 0.05x. And then we'll divide by this on both sides to get x alone. And so 50 divided by 0.05 is going to be 1,000. So we get that x is equal to 1,000. And so what this means is, let's write it as the group of friends will break even when they sell 1,000 cupcakes. All right. So you might see a question like this on your homework, and so that's how you would do that one.